Hello again. It's been a while since we were last together. Um, Hope you had a nice spring break, as it were. Our big adventure was we went to Wenatchee. Yeah, we were hoping to go to California at one time, but ended up in Wenatchee, so we'll take what we can get. So we're now going to move on to some new material, which we haven't seen in a while. And I just want to kind of give you a sense of where we've come from. We didn't get very far before break into this idea of solving quadratic equations, but we did get to the point of being able to factor quadratics and then setting those two factors equal to 0 using the zero product property and then solving equations from there. And that was really great. But we're about to move into probably the most complex work we've done this entire year. And I don't say that to try to scare you, but to help you understand that, look, this is April of Algebra 1. We're going to be doing some pretty sophisticated work. And to be able to do that work, we're going to have to be able to demonstrate this really important skill of simplifying radicals. So, and radical is just, a square root for now. So today's lesson and then the next couple of days of review are just going to give you an opportunity to practice this skill, look for how you can apply it so that when you get to a point where you have to apply it, you know what you're doing. Okay, so we're going to take a look at radicals. And to start with, I'm going to give you a very simple one. Square root of 16. Okay, most of us can think about that. We've talked about this a lot in class. What times itself equals 16? And the answer is 4. And that's all we're going to say about that at this point. There's going to come an issue later in the week where we have to change a little bit of how we think about that kind of problem. But for now, square root of 16 is 4. Great. All right. So now, what about the square root of 12? Now we got a problem, right? We know the square root of 9 is 3, square root of 16 is 4, and 12 is somewhere between 9 and 16. So we think, well, it's probably somewhere between 3 and 4. Oh, I know. We'll just punch it in a calculator. Get my fancy calculator out and punch it in and get an answer. But that's not how we're going to do it. The calculator only gives us an approximation of the answer. We're going to want an exact answer. Now, here's what we're going to do. I can think of the square root of 12 as the square root of 6 times 2, which I can write as the square root of 6 and the square root of 2. One of those cool properties of square roots or radicals of any kind, actually, is that you can split a radical into 2 parts. But the problem is this is bad. Why? Because I don't know what square root of 6 or square root of 2 happens to be. Again, I can put it in a calculator, but all that does is gives me an approximation as a decimal. It doesn't tell me exactly what it is, not like square root of 16 equals 4. So that particular approach isn't terribly useful. However, I can think of a different way to break this down. I can think of other factors of 12, that is, numbers that multiply together to make 12, and they are 4 and 3. Yeah. So why is this useful? Because of this. And I want you to be sitting there thinking, I know what the square root of 4 is. That is 2, and then I have the square root of 3. And indeed, that would be correct. The square root of 12 simplifies to 2 times the square root of 3. I've taken a factor whose square root I do know and simplified it. I've taken a factor whose square root I don't know, I left it alone. So this is going to be how we approach this idea of trying to simplify radicals. All right, ready for example number 2? Here we go. What is the square root of 50? Now, in your mind, you might say, it's pretty close to 49. I know 49 is, the square root of 49 is 7. So this is a little bit more than that. I bet it's 7 point something. but I want to get you to switch that mindset. I want you to get away from thinking about decimal numbers and thinking about two numbers whose product is 50, but one of them is a perfect square. So while you're thinking about that, let me show you the wrong way to do this. I don't really like to do this very often, but here's one way you could do it, which is wrong. Now, you should be saying out loud why that's wrong. I mean, it's not wrong that 10 times 5 equals 50. But this is the wrong way to simplify the square root of 50 because I don't know what either of those numbers is. So I don't want to pick that one, but I bet you by now you can think of another one that might work, a combination. Did you think about 25 and 2? If you did, then the square root of 25 is just 5 and the square root of 2. So what we're going to be looking for are these numbers. I'm going to write them over here. 1 is not terribly useful as a factor, but 4 is, 9 is, 16 is, 25, 36, 49. Those should look familiar to you. 64, 81, 100, and it goes on and on. If you can take any number and break it into two factors, where one of those factors is one of these numbers on the right, then you're well on your way to simplifying square root. All right, so having done that, let me throw out to you example number 3 and see what you think about this one. This is going to be the square root of 63x to the 5th. See what I did there? I stuck that x to the 5th in there, and that's going to be a little bit tricky for us as well. So I don't expect you to know that today, but in about 2 or 3 days, I do expect you to know how to do this. So let's go through this problem one step at a time and see if we can make some progress, okay? The first thing I'm going to do is break this into 63 at x to the 5th. So I want to tackle the square roots of numbers differently than I attack the square roots of variables. And I will say the number part's going to be probably a little bit easier, and the variable part's going to be a little bit harder. Okay, so now what I want you to look down this list right here and see if you can find a number that goes into 63. And you might know already, but there's a couple different ways to get to 63. I want to pick one of those as one of my factors. And while you're thinking about this, what you can always do is you can take your calculator and take 63 and divide by each of these numbers and see what comes out. Obviously, it takes a little bit of time, but it might help you. Anyway, what I'm hoping you came up with is that. Can some of you come up with that? So that 9 times 7 makes 63, but this now simplifies to just 3 and the square root of 7. So this is the simplified portion of the number part of this overall expression. Now we're going to have to tackle the variable part. And this is going to be a little bit tricky because I now have to think about some combination of x's that I can take the square root of. So let me ask you this. Does that simplify? It'll be x to the 1. I hope you said out loud, no, it does not simplify. Does that simplify though? Is there something I can multiply by itself to get x squared? And the answer I hope you say is x. Think about that for a second. The square root of a number, we'll go back here. The square root of 16 was the number you multiplied by itself to equal 16. So the square root of x squared is a number you multiply by itself to equal x squared. Great. What about x to the 3rd? Is there anything I can multiply by itself now to get x to the third? And the answer is no. In fact, you can't do this with any odd numbers, but you can do it. You can do it with even numbers. What expression times itself equals x to the fourth? X squared. If you're not sure what I'm talking about, watch this. If I take x squared and then I square it, I get x squared times x squared. And now, aren't you kind of glad we did all that work with exponents? Because this is now x to the 2 plus 2 makes 4. So the square root of x to the fourth is x squared. I can take the square root of x to the fourth. So watch what I'm going to do here. I'm going to turn this into square root of x to the fourth. Whoops. The square root of x to the fourth, which I can take the square root of. And then I also have an x to the 1 over here. I got to have 4 plus 1 makes 5. So I've taken and broken x to the fifth into these two factors, one of which I can take the square root of, one I can't. The one I can becomes x squared. The one I can't is just square root of x. So now I have this whole number right here. I know it's got variables in it, but it's a number. And the question then is, how do I put that all together? Well, I squeeze together all the things that I did simplify, like 3x squared. And then I squeeze together the two things I didn't simplify is one big square root of 7x. Wow, look at that. That's something. I'm guessing that when you first saw this problem, you did not necessarily anticipate it turning into 3x squared times the square root of 7x. That's pretty high-end stuff right there. I would definitely not expect you to just know how to do this on the very first day. But that's the kind of work we want to be able to get to in the next couple of days, okay? Okay, I have two more examples for you, and I just want you to follow along and try to practice this as we're going through it so that when it comes to doing your assignments, you've got a little bit of experience. And I promise you, the more you do this, the better you're going to get at it. This is one of those skills that every time you do it, you get a little bit better. So here we go. Square root of 5 times 2 square root of 5. What? Now this is not even a simplifying problem, this is a multiplication problem. So let's see how we do this. What we're going to do is so remember when you multiply, you just multiply everything together. There's no order to it or anything. So I'm going to change this around. I'm going to put the 2 in front, times the square root of 5, times the square root of 5. And you might look at this and say, oh, I know what happens when I take the square root and multiply by itself. And if so, that's great. But if you don't, here's what we're going to do. I'm going to write this as 2, and then I'm going to write this as the square root of 5 times 5. So I went putting them together rather than taking them apart, which I'm allowed to do. And this becomes 2 times the square root of 25. We know what the square root of 25 is, right? The number times itself that makes 25, which is 2 times 5, and we get 10. So this, all the way through, equals 10. So I want you to look for opportunities to take radicals, combine them together into a single radical, which you can then simplify. Okay, so we'll be doing a little bit of that. Again, these examples here, we were simply simplifying a radical as far as we could. Now we're actually looking at operations with those radicals. This is a multiplication problem. And the last example I have for you is going to be an addition problem. And this is, oh no, I take it back, not addition. Just another multiplication problem. I thought I had a multiplication problem, an addition problem, I know. Okay, so last problem here Now this is a little bit confuzzling, yeah? Okay, here's what I see first. I see a 3 we can put out front. I always want to put the numbers, the ones that are already simplified, put them out front. And then I have this square root 7x, square root 10x to the 7th. I got to do something with those. Well, I know that I can take the 7 and the 10, make that square root of 70. And I also know that I can take the x to the 1st and the x to the 7th, make x to the 8th. You see what happened there? 7 times 10 makes 70, x times x to the 7th makes x to the 8th. Now, here's the problem with 70. Let's go back here to this list. Look down there. Do you see anything there that goes into 70? 4 doesn't go into 70, goes into 80, doesn't go into 70. 9 goes into 72, 16 goes into 64, 25 goes into 75, 36 goes into 72. All the other numbers are too big. So nothing goes into 70. So I can't actually simplify that any further. Yes, I could write two numbers whose product is 70, but if I can't find the square root of at least one of them, then there's no point in doing it. However, I can find the square root of this. I have to ask myself, x to the what squared equals x to the 8th. Like, what number do I put right there that'll give me x to the 8th? And I hope you are seeing a 4 that goes there. Because x to the 4th times x to the 4th, 4 plus 4 makes 8, is x to the 8th. So when all is said and done, what I have is I have 3, the square root of 70, and x to the 4th. And it's kind of a funky way of writing it. We could write it that way, or it's also sometimes written as 3x to the 4th square root of 70. I know that looks weird, but sometimes it just gets confusing, like where the radical changes. So I would accept that form or that form when you're doing these problems. Okay? So this is a little bit tough. This went from, we started a few minutes ago with the square root of 16, and now we're out doing the square root of 7x times 3 times x to the 7th. That's pretty heavy stuff. What I want you to do is to give yourself some time to learn this, to practice this, and to feel confident with this. So here's what we're going to do. Assignment number 5, which is going to be Tuesday's assignment, is page 373 out of your book, 7 through 12, 16 to 19, and 27 to 45, multiples of 3. So that's 27, 30, 33, so on. Then for Wednesday, you're gonna have a CUDA worksheet on the website. Ones that look, oh my goodness gracious. It looks like radicals. And I'll show you how to find that. I want you to remember, answers are included. So you don't get any advantage, right? Write down the answers. If you just write the answers down, it doesn't do any good. Do the problem, check your answers. That's what I'm saying. We don't really have a chance to go over this so much like we do in class. So that's how you check your work. And then so this is Tuesday, Wednesday, Thursday. On Thursday, there's a worksheet that says do now on top. And you're just going to do page 1, 2 through 20 even. Okay. So let me show you what that looks like on the on the website. Give me just a second to pull this up. If you are able to get to the website, it'll look like this. We'll go to assignments. And we'll go to April 13th. And you will see this link will be active once I'm done recording this. You will see Tuesday's assignment there from the book. Then Wednesday, Thursday, those are all down here. So there's CUDA Radicals, page 1, Do Now worksheet. Just click on this and you'll see it says at the top, Do Now. See that? So that's what you're going to be looking for. So good luck, work hard. Fourth quarter is starting this week. I want you to do as well as you can so you still can pass fourth quarter, earn yourself the credit, and move on to much bigger and much better things down the road. If you're stuck, text me, call me, email me. I'm here for you guys. I miss you. I hope you're well. Stay healthy. I hope to see you and talk to you real soon.